Now, China's one small step could be a giant leap for humanity, creating an artificial sun. Yes, you heard that right.
Imagine a world where we can harness and replicate the power of the sun right here on Earth. It sounds like something out of science fiction, but that reality is becoming more achievable. China has recently announced a significant technological milestone with its creation of a man-made artificial sun. The experimental advanced superconducting tokamak, or EAST, has the potential to transform how we generate energy by imitating the processes that power the sun. This breakthrough could lead to a future of cleaner and more abundant energy worldwide. But what exactly is an artificial sun, and what implications does it have for the global community? Stay tuned as we delve into this groundbreaking development that could change the future of energy production. China's artificial sun, known as the Experimental Advanced Superconducting Tokamak, is an impressive scientific device designed to imitate the nuclear fusion process that powers our sun. Nuclear fusion has the potential to provide nearly unlimited clean energy. Unlike nuclear fission, which is used in today's nuclear power plants and involves splitting atoms to create harmful radioactive waste, fusion works by combining light atoms like hydrogen to create heavier atoms, such as helium. This process releases a huge amount of energy. EAST aims to harness this fusion energy, which could transform how we produce power, making it cleaner and more abundant for everyone. The Experimental Advanced Superconducting Tokamak, EAST, also known as China's artificial sun, has been in development for over 10 years and marks a significant advancement in the global pursuit of fusion energy. This machine is shaped like a donut and uses very strong magnetic fields to contain and control superheated plasma, which is the fourth state of matter inside the reactor. Scientists aim to heat this plasma to temperatures over 216 million degrees Fahrenheit, hoping to maintain a nuclear fusion reaction long enough to produce more energy than it consumes. Before EAST, France's Tour Super Tokamak held the record for the longest plasma duration at 6.5 minutes, achieved in 2003. In 2016, South Korea's Korea Superconducting Tokamak Advanced Research K-STAR reactor set a record by maintaining a temperature of 50 million degrees Celsius, 90 million degrees Fahrenheit, for 70 seconds. EAST broke K-STAR's record in 2021 by sustaining a temperature of about 119 million degrees Celsius, 216 million degrees Fahrenheit, for 102 seconds. Additionally, in May of the same year, EAST set another record by running for 101 seconds at an impressive 120 million degrees Celsius, 216 million degrees Fahrenheit. For comparison, the core of the actual sun is around 15 million degrees Celsius, 27 million degrees Fahrenheit. Now it's important to know how nuclear fusion works and why it's so important. Fusion happens naturally in the cores of stars, where extreme pressure and heat cause hydrogen atoms to combine and form helium, releasing energy in the process. Replicating this process on Earth is challenging. In the Sun, temperatures reach about 27 million degrees Fahrenheit, but on Earth, scientists need to create even higher temperatures, over 100 million degrees, to make up for the lower pressure and gravity. The process starts by heating hydrogen gas to very high temperatures, turning it into plasma. Plasma is a hot, ionized state of matter that allows nuclear fusion to occur. Once the plasma is created, strong magnetic fields are used to keep it contained within the reactor, preventing it from escaping and cooling down. If scientists can achieve stable and sustained fusion, it could provide an almost endless source of clean energy, with hydrogen as the main fuel, which is plentiful in water. The major advantage of nuclear fusion is that it produces no greenhouse gases and very little radioactive waste, making it a much cleaner option compared to current energy sources like coal, oil, and even fission-based nuclear power. Additionally, fusion is safer because it doesn't involve chain reactions, which means there's no risk of catastrophic nuclear accidents like those at Chernobyl or Fukushima. China's progress with East is a crucial step toward making practical fusion power a reality, but there are still many challenges to overcome. The ultimate goal is to reach a point where the fusion reaction produces more energy than it uses, known as net energy gain. Once this is achieved, we could see the development of fusion reactors that can power cities and industries with clean, renewable energy. Nuclear fusion reactors can transform charged particles into electricity using unique techniques like plasma waves and magnetic fluids. This technology has the potential to be used more diversely and efficiently in the future. China's artificial sun is not intended to be a source of light or heat, but to live safely in a facility that can withstand its high temperature. As a byproduct of its operation, clean energy has reached a new pinnacle with the creation of nuclear fusion power. This process replicates the burning of stars by fusing hydrogen atoms under tremendous pressure to produce helium, similar to the process at the sun's core. Nuclear fusion uses the plentiful hydrogen atoms found in the ocean without producing any carbon dioxide, generating an astounding amount of energy. This renewable energy source would drastically alter the fundamental calculation of life on Earth. China's first artificial moon is being implemented in the eastern Jiang area of China, using a reflective coating to redirect sun's rays towards large solar panels. The satellite would have 8 times the brightness of the real moon, emitting a dusk-like light. Fusion energy development is a global race involving major players like the United States, Russia, and the European Union. China's advancements in fusion technology place it at the forefront of this race with the International Thermonuclear Experimental Reactor (ITER) project aiming to develop the world's largest fusion experiment in France. China is investing heavily in domestic fusion research with projects like EAST, which could reach significant milestones before 2035. In 2023, China unveiled HL3 tokamak, another artificial sun reactor capable of reaching temperatures 10 times hotter than the sun's core. This puts China in direct competition with other fusion initiatives, including those in the US, where companies like Commonwealth Fusion Systems are working on compact fusion reactors. Fusion energy represents a massive opportunity for energy independence and global leadership in clean energy innovation. China's success with fusion energy could have far-reaching consequences for global trade, energy security, and climate change mitigation. However, there are still significant hurdles to overcome before fusion energy can be deployed on a commercial scale. The key challenge is achieving net energy gain, where the energy produced by the fusion reaction exceeds the energy required to sustain it. Advances in superconducting materials, plasma confinement, and reactor design are bringing us closer to a future where fusion energy is commercially viable. Fusion technology is a highly competitive field, with the United States, China, and Russia leading the pack. The US team, led by Commonwealth Fusion Systems, aims to achieve a net energy gain by 2025, while China, a relative newcomer, is a formidable rival in the field of conventional nuclear energy. China has achieved milestones in energy development, such as activating its artificial sun using a Russian-designed reactor. The experimental advanced superconducting tokamak EAST project, funded by 300 million Chinese yen, 37 million, is being developed and operated in Anhui Province, China. The project has achieved several milestones, including maintaining H-mode plasma for over 30 seconds at 50 million Kelvin, reaching 100 million decus electron temperatures, and setting new world records. China is also working with the International Thermonuclear Experimental Reactor in collaboration with 35 other nations. The quest for a commercially viable fusion reactor remains a highly individualized endeavor for China, with competition being more intense than ever. China has successfully activated its nuclear fusion reactor, creating a lasting legacy in nuclear power research. The HL-2M tokamak reactor, China's most advanced nuclear fusion device, uses a strong magnetic field to fuse hot plasma, potentially unlocking a more potent clean energy source. Since 2006, Chinese scientists have been developing miniature nuclear fusion reactors for use in the International Thermonuclear Experimental Reactor project. The East Tokamak reactor has broken multiple world records for plasma duration and temperature and has also shown promise for space travel. NASA has achieved nuclear fusion on a small scale using lattice confinement, a mechanism that condenses and controls energy produced by fusion reactions. Thank you for joining us on this fascinating journey through the world of nuclear fusion and China's artificial sun. As we've seen, the potential for fusion energy is immense, and the breakthroughs happening today could reshape the future of energy for generations to come. If you found this video interesting, don't forget to like, share, and subscribe for more updates on the latest scientific advancements and technological innovations. The future is bright, and with the power of fusion, it's only going to get brighter.